Okay, let's understand now about the color blindness. Color what? Blindness. Blindness. And we're saying this color blindness, how do you differentiate them? We are saying on the color blindness, this is where an individual fails to differentiate some common colors. And which are these common colors? Red and green color. Red and what? Green color. So let's do the genetic roles, and we are saying this one is linked to the X chromosome, right? So let's do this. Maybe an individual was normal. We have a normal female. We are speaking about the male can either be normal or hemophilia or colorblind. Then again the same way, but the female can have three chances. This female can either be, we are speaking about X, what? We use capital C for a normal individual. Then we have again still X, capital what? C. This one will be a normal female. Normal what? Female. Then we have the carrier female, which will be X, capital C, X, small c. That is our carrier. And our third, we have X, small c, X, small c. That will be what? Colorblind female. Colorblind female. On the other hand, we have the male, and on the male can either just have a chance, which will be being normal, so that is a normal male. And there are one, we have either being what? A colorblind, colorblindness, a colorblind one. So let's use the genetic cross. We cross now just a normal female, a fully normal. So it means this one will be homozygous. No, that means this person doesn't have any trait of color blindness. We cross with a normal man, all our offspring will be normal. If you use a carrier, like the one that we had used in our previous, that is for the hemophilia, it means what will happen? We can go and use the color blind. We will have a 50% chance of getting a child who is colorblind. Then if you use a colorblind female, let's do our cross using a colorblind female with a normal male. Colorblind female. So we are speaking about the female side is this one, and we're doing with colorblind female. That is our parental phenotype. Our parental phenotype should be colorblind female. I'm saying you cross with a normal male. So our male sign is this one. So we have our normal male. Then we have your parental genotype. And on this parental genotype, what are you using? This is a colorblind. So for the colorblind, it will be X, small c, X, small c. Then you do a genetic cross, but today let's use a Punnett square. Then now this one, we have the normal male, which will be X and capital C, then Y. And I've said let's use what? A Punnett square. Let's go to gametes. This gametes here will be X small c, X small c. That is our color blind, right? Then you have your X and capital C. Then you have your Y. Y is not linked to anything, right? Our Punnett square, you draw the square. That is our square. You divide it to some three sections. First, second, then again you divide 3 times till. That's how we do our Punnett square. The square should be complete. The rules, like the genetic rule, remains the same. There should be no extension. There should be no hanging line. This is how you divide the gamete line. Let's say this one is our male, this one is our female. And our male, this one's for our female. So it's what? X small c, then X small c. Then for the male will be X capital C, it's a capital C, then Y. Then what? Y. It should not touch any of the lines, sorry. So we are saying it should not touch any of the lines. Then from that point now you just fill. So you start with the capital, that is X capital C, then X small c. The second one is X small c, Y. Then the third is X capital C, X small c. Then the next one is X small c, then Y. So from that point, our phenotype, our F1 phenotype, this one will be that sufficient. So the F1 genotype, the phenotype, our F1 phenotype. Our F1 phenotype will be what? You can check from this one. You have found what? X capital C, X small c. Then you have again X capital C, X small c. Then you have X small c, Y, and you have X, this one is X small c, Y. X small c, Y. So what does it mean? It means our females are normal. These females are what? Normal female. But we are saying these normal female are what? Carriers. So it means they have the gene for what? Color blindness. But their daughters are just normal when you check them. These male here, our sons, that is the male, are all color blind. They're girls, they are color blind. So it means if the female is a carrier, definitely their sons will be purely what? Colorblind. That is how the genetics works. And in the real life situation, for the female and for the male, before they get married, it's good to check about these disorders. If you carry one, you should know how you can control it. So this is showing you clearly that you can transmit a disorder to your children. So, and this one, according to a genetic rule, it's a crime to transmit a genetic disorder to your children. They can sue you and you can be arrested for doing that to your individuals. Thank you very much. Our next slide, I'll teach you about the one for what? Those which are linked to the Y chromosomes. Thank you very much. Just do what? Subscribe and you like, so that we can continue to understand more and understand more of the genetics, even about the protein synthesis. Thank you.